So today the plan is I'm going to go into a demo of RemoteView. And as a refresh, just to remind everyone what RemoteView is designed to do is remotely troubleshoot users who are working either at home or in the field. It can also be used inside a corporate environment to be able to find out, is there a problem with a laptop's connectivity? Is there a problem with a laptop wireless signal strength, channel, all sorts of information. So let's dive into exactly that. So the demo is right here. So TotalView will install relatively rapidly. If you're not using it to monitor the rest of your network or the other features, and you're just focused on the RemoteView part, then this is really just a 10-minute deployment. What's going to happen is it's going to install, and you're going to be able to come right here to the RemoteView tab. And at this point, what you can do is say, let me email a link to a user and have that user download and run the agent. Now, again, the agent can be pre-deployed. You can download it here yourself and run it, but it's a single executable. And that single executable looks like this. So they're going to run that. It's going to come up, and all the user has to do is just click start. At that point, it's going to run a level 4 diagnostic. You can choose whatever script you want to run. If you want to tell them, hey, I need you to run a level 1 diagnostic. And yes, there's a little Star Trek we threw in here, but effectively, it's that a level 4 is system tests, and then we get down to level 1 where it's doing the system test, a full network test, all the wireless tests, web fetch tests to try and diagnose what's going on. All of those are going to automatically collect the information, batch that information, and then send it back to the server, at which point you get a notification email saying the user finished running the test. Now, just like a doctor saying, okay, the lab results are in, I get to evaluate what's going on, you're going to come in and say, oh, okay, here's Steve. Looks like he ran the level 1 diagnostic I asked him to run. Let's go through the results. First thing I want to do is learn about their system. Click on System Information, and I see that they're running Windows 10 Pro. It's on a Surface Pro 3 computer. I get to see how much memory there is. I get to see information about the network cards. So all sorts of internals about that computer. Okay, I wonder what's running on that computer. Click on Process List, and I get to look through to see what's taking most of the memory, what's taking most of the CPU. Maybe you scroll down here and find out it's running World of Warcraft, and you figure, hey, that's just not going to work when you're running business applications at the same time. You find the network adapters and say, these are the adapters. In this case, we have just one dedicated wireless network adapter, but if you had multiples, you'd get to see if there's multi-pathing going on. IP config information, routing table. Here's the speed test. Well, we can see very quickly that the ISP is AT&T Uverse. Download is 81 megs, upload is 59 megs. So we get to see maybe there's something actually causing them to have a really low bandwidth. And you get to be able to validate that really quick. If you want stability tests done, this is effectively a call simulation. So this is simulating a voice phone call. So it's using G711. We get to see how many calls were tested, what the CPU was during the test, the amount of memory available, network I/O. If we had DSCP preserved, out of order packets, latency, jitter, loss, and MOS score. Now, we've got some jitter spikes here. They're not too bad, but it is a little concerning because if these did get worse, those jitter spikes could definitely cause some sort of audio or video problem. So if you're dealing with live streaming, this is a good way to automate that test from that user's perspective. Now, if you want to find out more about what's causing that jitter, we can dive right into the next type of test, which is a path stability test. So the path stability test, we're seeing the same sort of information, except this time we can click in at any point in time. So we see the jitter spikes and we say, okay, let's click in right here. And what we're seeing is at 3:54 and 3 seconds, this is the hop count. This is the trace route out to that endpoint. And I can see that latency is low, jitter is low, and there's no packet loss. What I can now do is go second by second to say, let's look at the next second. Okay, that also looks pretty good. The next second. As I get through here, I'm going to discover, whoa, okay, the jitter is incredibly high here, 110 milliseconds, and it's happening at my own firewall. Now, if this happened 3 hops in and the jitter happened for everything 3 hops in and behind, we'd say, hey, that's the ISP's router that's creating the jitter. In this case, the jitter is starting from my firewall and everything behind it is suffering as a result. So my firewall caused the jitter. So if it was the far end, let's say it's the carrier end that's causing it, you get to find out, where did the problem happen? Was the loss through your ISP? Was it a backbone provider? Was it the head end? So you can determine, where did these problems with real-time streaming happen and who can be blamed. Now, as I keep going through, I can see that another event happened with these jitter spikes. And again, it's my own firewall. So those jitter spikes that sporadically happen, I get to be able to target and say, yeah, I think we need to upgrade the firewall because that's where they're emanating from.
Hey, Tim, just a quick question. As you're going through those, on the right side, the scale is changing. So they're not comparative scale. The scale isn't fixed. It moves depending on the data you collected.
Yeah, we originally had it so that the scale would be fixed. The problem is that 7 milliseconds completely disappears when you have 111 milliseconds. So it effectively makes a lot of the data just completely disappear off the screen. And so we figured it's still valuable to be able to say, are we seeing things? So I understand what you're saying is, if you're not aware of the scale, and that's why we use color to end up drawing your attention.
Green is a tall green doesn't mean it's bad. It's still green.
Correct. It is still green. Exactly.
And can you set where that color changes?
So that's built into the program based upon the codec that you select. So when you choose a codec, it's going to choose a set of parameters saying, here is where that codec generally starts to say, we're not happy at this number.
And I take it when you say that the jitter is on your local firewall, that could be something on your local LAN before the firewall. That's just the first point you're recording it.
Correct. That's the first place that we're seeing it at that point and beyond. Now you're right in saying, is if this jitter was low to the firewall but high right behind it, then that's just beyond the firewall as to where the jitter is occurring. So it allows you to determine, was it the LAN and the firewall, or was it the firewall and beyond? Okay, so that is a path stability test. Other tests, we can look at the wireless test and say, okay, this remote user out there is connected wirelessly. We can see that they are connected to home WLAN, 2.4 gigahertz, radio channel frequency. We get to see the RSSI signal strength.
How do they get channel 36 in 2.4?
Exactly the same question.
I'm gonna apologize and say I'm embarrassed because this is a canned demo, and I mixed that up apparently. You caught me. You fair catch. So what I'm mimicking here, or attempting to mimic, is that you end up having poor signal strength when you have a microwave going on, and then better signal strength when the microwave finishes. So this was effectively a canned demo that effectively I'm failing at, but you get the gist as to what we've designed.
Can that one drill down on the wireless RSSI as well?
There's no drill down. I mean, you can hover over and it shows you the specific numbers above. So right up here, you see the specific RSSI signal strength, quality, network I/O. So all these stats update when you move the mouse around.
Is there a way to expand kind of the scale laterally there? So if you want to see those bars a little better without using browser zoom?
Currently, no. Good point. There is the ability to have this test also saved as a CSV file so that you can do your own reporting in Excel. That way you can just graph it out and say, here's how I want to see it.
Thank you.
Is there any correlation between the data from these different tests? So I'm thinking we've seen jitter at the local firewall. Actually, there was also high retries at those points on the wireless. So it's probably the jitter's been caused by the wireless, not the firewall. Is any of that sort of correlation?
So no, not yet. But the interesting thing is you're seeing what we're aiming for. So you've just spotted our roadmap. What we figured is this whole solution was really designed very rapidly to get it to market for COVID so that people could say, I need this troubleshooting ability. I need non-technical users sitting at home being able to run something that will gather all this data, send it back so it can be analyzed by somebody. And so our next step is to be able to say, let's have all of this information commingle because we have it, and then be able to do that analysis and say, if A, then B, then C, and put it together and say what's going on. So you've just spotted our top secret roadmap of where we're going.
Great.
Next test I can share is our SSID list. So we're able to capture off of the remote user to say, here is their neighborhood. So they're connected to home WLAN. These are all of the SSIDs they're seeing in that environment. We can do some filtering here and say, let's filter for channel 1 and say, yeah, there's a few other neighbors using that same channel. Therefore, if we wanted to recommend that they use an alternate channel, we could just do the drop down and see what are the channels that are not in use and recommend they use that. Yeah, so we found a number of customers they're in apartment complexes, extremely dense environments, and there's just so much stomping of signals in home environments that that's almost the #1 problem that people are fighting with these days. Other tests that tend to be useful collecting from those home users is their LAN devices. So we can end up discovering all of the devices in their LAN to say, okay, here's their default router. Looks like it's a Ubiquiti device. They have some HP devices, some Apple devices, but it's easy to support the user because you can tell them, oh, well, your Ubiquiti, it's responding to SSH and web and HTTPS, so that's how you would manage that device. That way you don't have to say, well, I have no idea. Can you try and open a web browser to it and not have it respond? This way you can tell them, it does respond to a web request, open a web browser and target that IP address. Other tests that we have is for web pages. We can do web screenshot fetches. This is sometimes useful if somebody says, no, the page doesn't look anything like what you're talking about. Well, we can do a web screenshot fetch and say, okay, let's see what the screenshot looks like and have that automatically scraped and sent back to us so that we can say, oh, this is a caching server and it's saying that you don't have authentication and it's not letting you actually browse the page. Also, for solving slow web pages, you can actually have it do a web waterfall test. So here we've done a web waterfall test for just MSN. And if we scroll to the bottom of this waterfall test, we see that the overall page load was 5,700 milliseconds. That's almost 6 seconds. Nobody waits 6 seconds for a page to load these days. So what's taking all that time? Why is this web fetch going so slow? Well, we look at the initial fetch and we say, what the heck is this long bar here? You hover over this and it's going to show that the connection was stalled for 2,500 milliseconds. After that stall, it did a very quick DNS lookup, a very quick connection, very quick SSL negotiation. The request, time to first byte was fast, download was fast. So, okay, it couldn't even do a DNS lookup and it was stalled for this huge amount of time. What would cause the connection to be stalled? Well, if there was antivirus or anti-malware that said, we're not letting you do a connection until we validate that we want you to even try doing that connection. Once it validates its lookup, then it will permit the connection to go through. So we're going to ask to say, hey, is there antivirus that's actually preventing this? And thus it's causing the slowdown. And then we need to research what can be done to minimize that slowdown. Now, if it was some content piece like an image, it might be a caching issue. If it's some JSON, it might be a database slowdown. So we're able to help troubleshoot and debug what is causing each of these pages to take too much time, thus making the page load very slow. So this is just a small handful of tests that we've scheduled in a default level 1 diagnostic, but if you can remember from the presentation yesterday, there's a whole litany of tests that you can prescribe to say, this is what I want my users to do when I ask them to do a test. That way the right information is brought back so that the analysis and troubleshooting can really only be a 1 or 2 minute session to say, I can now diagnose what the problems are in your home network.
Pretty good. I had a quick question. I think you answered it, but I wanted to know how long it takes to run the test. I think you said 1 to 2 minutes. Is that right?
It completely depends upon the test. You can actually have it do certain fetches, certain tests that might be just seconds. Getting CPU information, getting process information, getting system information might be just a few seconds. But if you prescribe to say, I want you to do a 30-second link troubleshooting test because we're looking for things that are causing video artifacts or audio artifacts for a video conference or UC, that might be a 30-second test.
And the data is sent directly from the RemoteView tool to the cloud, right?
It's directly to the TotalView server, which if you house your TotalView server in the cloud, yes, it does. You can, though, run that TotalView server internal, and there's many organizations that just say they don't want to ship this kind of data to the cloud, and so you can make your own choice as to whether you want it in the cloud or not.
Okay, and how would you help users that just say, I'm not connected to the network or I can't connect? Do you have any? Is it even like a tool we could use for those purposes, or it wouldn't really work if you don't have the connection back to the network?
Well, so it'll run the tool. It's going to have its last seen script. So if the scripts are there, you can then say run the script. It will do its tests, but it won't be able to send the data back up to the TotalView server. It will batch the information, though, so that the next time you do connect, it can send the data. And what that means is you can have a user saying, hey, I can't connect. You say, okay, well, go ahead and run a level 1 diagnostic. It's going to perform the tests, not be able to send the data back. And then you say, okay, go connect to your other network that does work. And maybe it's on a cell connection or otherwise. And it will get the data shipped up. And they can say, okay, when you're on your home network, here are the problems. It's a DNS issue. You're not getting proper DNS resolution. Therefore, you're not getting out.
Thank you, Tim.
Are there any plans to, let's say, aggregate all this and make it where you could, say, schedule a certain set of level 4 reports once a week and then shoot them all off and then have them displayed?
So some of that can be done today, but in one sense, so what you can do with a script is you can loop the script. You can say, I want to have this run every hour on the hour, or once a week, or however often you want. So that can be looped. All they have to do is just start it, and it will end up saying, okay, it's running in the background, doing its thing, where every hour it's going to be doing its checks and sending the data north. As far as having you be able to remotely schedule and script that, that's the part that we're still working on.
And if you've got something running regularly, will that show as separate tests in the UI, or will you be able to aggregate the data and look at it over time?
It'll be separate tests, and each test will end up having a red dot or a green dot, so that way your eyes can just go in and say, okay, all these tests were good, but at 3:35, this test was bad. Let's drill into that one.
Okay, that's good, because very often you get intermittent problems. So you just want to leave something running for when the issue occurs.
Yeah, and so if it's running continuously in the background, watching that, every time it ships a test out, it's going to send a success or fail notice, and that success or fail is completely defined by you to be able to say, for example, if packet loss is greater than 3%, mark it as failed, because that's going to lead to call quality issues. It's going to lead to unhappy users, and that way you get to decide what is the threshold for that poor quality call.
How does it decide on the server that it uses for the speed tests? For example, I have a gig speed here. If I would run a test with a certain servers, I couldn't sometimes get more than 100 maybe, or 150, and some other servers I can easily get the whole 1 gig. Does it use Okla, or how does it perform this?
So the speed test that we use is come on, brain. I'm forgetting the API that we're using here. I think it's speedtest.net. And so we're using their API.
Yeah, it says UCLO in the HTTP address. Yeah.
Jim, how are your agents bundled and sold, or how's the agents and the server bundled and sold?
So what we'll do is we have really a couple different bundle options based upon the size of your user community. So if you say, gee, I've got 1,000 users, 1,000 users that I want to support, or I have 5,000 users or 20,000 users. So if you give us the number of users in your environment, we'll end up giving you a price that ends up covering 100% of your user base. So it's, in one sense, it's very simple pricing. We're not making this, incredibly complex where we're counting CPU cycles or we're counting amount of tests that you're going to run. It's, you get all the tests, you get all of your users. We just end up putting you into a ballpark bundle that matches the rough size of your user base.
Are there plans to make parts of this more secure? I'm not saying it's not secure, but there's always improvements like segregation. You said you could put all on-prem, that kind of thing.
Well, so we've kind of done that for security. And the thing is you can put it on your own server, on-prem. You can put it on your own cloud server in the cloud. It's really up to you. And the reason is that we found some organizations just say they do have to support workers that are in their own office, but they're not actually able to connect to a cloud server, or they're restricted from connecting to other cloud services. So by the fact that you can run this internally to your organization just frees you up to being able to say nothing goes to the internet.
So
does it
have a native sort of encryption protocol between them, or?
It's using standard HTTPS TLS 1.2.
Do you have like an MSP model for this as well?
So we do have an MSP module. So yes, I guess talk to our sales team and they can talk about how that's licensed for MSPs. And
Mac OS support, is that coming anytime soon?
So that I think I mentioned yesterday. So good segue for that is that is on our roadmap. Is we're going to be building Mac OS second, and then we're going to focus on iOS after that, and then Android.
Is it possible to run like an iPerf test to get the throughput between, let's say, the customer, laptop and a specific server, and then the company?
Yes. Yeah. So it does have that ability. It's not iPerf, but it's effectively what we have is our own TCP Packet Pump, and so that's built into. That's one of those tests that we have, and you just select that test, choose the server that you want to end up testing to, and it will give you the throughput numbers. And what's kind of interesting with that is, you can have it run, and if you make changes to the network, you can end up seeing that flex up or flex down as the TCP sliding windows allows you to get more bandwidth through. So it gives you the ability to tune your network and find out what does this look like as far as, is this getting us better performance or worse performance?
Thank you.
Do you have any APIs that people could hook into?
So all of the resulting reports are obviously HTML. So you can go through and digest the information that's in here. So it's all in here. So yes, there's an API that you can suck that data. And these HTML, they are single file HTML. So it's MIME encapsulated HTML. So there's no externals needed. There's nothing that needs to be downloaded. And so in that sense, whatever elements are needed are completely baked into that one file.
What's the NetAlly tab for on the left?
So we've integrated with NetAlly. We're actually the only company that has done an integration where we can find all of the NetAlly analyzers throughout an infrastructure, be able to look at them, inventory them, find out which switch and where they're connected. You can click into any one of them, find out all of the tests that were run on those units. And then you can click on any one of those tests and we immediately dive into their link live to show the test results. So
hey, that's cool. Why didn't you lead with that? That's actually pretty.
That's very impressive, actually.
I like that a lot.
Yeah, we're a real close partner with NetAlly. And we can inventory them, find out the models, firmware versions, serial numbers, contact information, location. If somebody lost one, it's like, okay, it's on this switch and plugged into this port. You can find out where they are.
What is doing that discovery?
So there's two parts of it. First is we have an API to their Link Live to be able to scoop up data from Link Live. And the second thing is we put this together with all of the rest of our network management. So in order for this to function, we're effectively looking at all of the switches, routers, gateways, firewalls in the infrastructure, and we can say, here's where those devices are. So this is part of the greater network management piece that we have. Of which I'll invite you to look at the network field day that we have a presentation on this.
And is that like a bit of software you run on your network, or what's?
Yep. So this runs on your network. It'll find all your switches, routers, gateways, pull that information. And again, the trick here is automation. If you can kind of see what our whole unique, what do we bring to the game? Because there's a ton of network monitoring solutions that are out there. The problem is that with every network monitoring solution, you say, oh, go monitor this switch, then go collect this OID. Then I want you to collect the inventory. Then I want you to transmit bits on this interface. And so you have to build out collecting information on devices, and you never really find out what's broken. What we figure is if we find a switch in your environment, we're going to automatically monitor it. We're going to automatically monitor every interface on that switch, and we're going to collect all of the error counters. If you're dropping packets for any reason, we're going to be able to go in, see what's happening on this switch, see that there's a problem with interface 5, realize that that problem relates to packet loss. We can see what's connected there is a single MAC address that's associated with the HQ voice VLAN. We can see that that's a Dell computer, and it has a name voicemail record. So that's our voicemail recording server. So if we have packet loss to that server, that's going to lead to choppy sounding voicemails. We can then click in, we see the utilization, we see the packet loss, and we have a plain English diagnostic of what's causing the packet loss, because we have a lot more error counters than any other product. In fact, we can go over and see all 19 of the error counters so that we can say, yeah, you're dropping a ton of FCS errors, you have some deferred transmissions, and some outbound discards. And all of these error counters, what they mean put together is you have a cabling fault. Based upon the interface type and configuration, it has a heuristics engine that gives you the plain English diagnostic so that you can get the problems resolved. So it's looking a lot deeper at the network and a lot broader so that you really know more about what's happening on your network than with any other solution.
Great. And I take it the map tab is like a automatically generated map, is it?
Well, so this is for your NOC. This will show live updating status of links, devices, utilization on and status of things. Every 5 seconds, it's going to automatically update so you know which links are saturated, which links are down, what's going on with certain sites. The diagram, though, is the automatically generated network diagram that shows here is how your network connects. And this is all baked in. There's no separate upcharge for each of these modules. We look at this and say, this is all stuff needed to be able to run a perfectly healthy network. We have network automation built in, so we'll back up configs. We'll notify on config changes. We can do large-scale configuration deployments. We have NetFlow, IPAM, server monitoring. So everything needed to run a perfectly healthy network from the core of the product.